The new Rover 200 series, following in the Rover tradition of elegant sports styling, engineered for quality to produce a true driver's car. A smooth, stable ride with fully independent suspension and two high-performance engines to choose from. Quality was the starting point for the 200 series, and a new £200 million manufacturing facility to produce the new K-series engine and its R65 gearbox mean quality has been built in from the start. Low-pressure sand casting techniques are used for greater accuracy, and process control ensures each engine undergoes 300 checks and measurements before leaving the factory. First models launched are the 214 SI, 214 SLI, 214 GSI and the 216 GSI. The 214 enters the market with the all-new 1.4 K series engine, designed to run on unleaded fuel and available with an exhaust catalyst to keep environmental pollution to the minimum. The single-point injection and MEMS engine management system optimizes fuel economy, while the 16 valves and double overhead camshaft develops a power output equal to most 1600cc engines. The 1.4-litre K16 engine is an all-alloy construction and has a revolutionary new method of build. The engine is sandwiched together and held in compression by bolts extending right through the engine. The main engine components are an oil gallery, a main bearing ladder, the cylinder block, a cylinder head and 10 head bolts to sandwich the engine together. They screw into a casting beneath the bearing ladder, which doubles as the main oil gallery. There is a cam cover with a baffle beneath the filler plug to prevent oil splashing around the breather pipe apertures. 16 valves are operated by direct-acting hydraulic tappets, driven by twin overhead camshafts. There's an alternator, flywheel, exhaust and an air filter. The cam belt has a life of 96,000 miles and has semi-automatic tensioning. The timing belt cover, alternator belt and sump complete the K-series engine. Lubrication for the engine is supplied from a crankshaft-driven oil pump, and hydraulic tappets provide quiet, efficient valve operation. A thermostat, water pump and oil pump are built into the engine to minimize connections and possible leak points. The tidy look to the engine is continued with the spark plugs protected under a cover. A quick tour around the engine bay shows the air filter, which is changed every 24,000 miles. A vapor trap inside the air filter housing prevents fuel entering the ECU and contaminating the manifold pressure sensor. There's a fuel filter on the bulkhead, a windscreen wash reservoir, an engine bay fuse box, the MEMS ECU, and hidden next to these is the coil with its plastic cover. The distributor is mounted on the end of the inlet camshaft. The oil filter is underneath the alternator and the oil drain plug is next to it on the sump. The K-series engine is designed to run on unleaded fuel, which is delivered by a single electronically controlled injector mounted in the throttle body. The inlet manifold is water heated and cold drivability is further enhanced with a manifold intake air heater. A feature of this new engine is that when renewing the engine coolant, the procedure is very different to other Rover cars. First, set the heater control to hot. Then undo the expansion tank cap and remove the remote refill point top. Then remove the bleed point screw and fill up at the remote refill point. When the coolant comes out of the bleed point free of bubbles, refit the bleed screw. Fill again at the remote refill point until it's full. Refit the cap and top up at the expansion tank. Then run the engine until the fan cuts in and then switch off. Check the level of coolant in the expansion tank and top up if necessary. Always use the engine remote refill point when renewing engine coolant to avoid air pockets. Only coolant top-up can be done at the reservoir expansion tank. The MEMS engine management system is very similar to that already used on fuel-injected Montegos. A single ECU controls the programmed ignition system, the fueling, and the idle speed. Incidentally, the ECU can also store intermittent faults in its memory, and these are displayed under interrogation by microcheck and cobest. CO adjustments and fault diagnosis are also made using microcheck or cobest. The ECU calculates the basic air-fuel ratio using the speed-density method. Density is found using the manifold absolute pressure pipe sensor, and speed is known from the crankshaft sensor. Other sensors enable the ECU to further refine the air-fuel ratio. An intake air temperature sensor helps the ECU refine its density calculation. The coolant temperature sensor tells the ECU how hot the engine is. A throttle potentiometer provides a signal to the ECU of throttle movement. The throttle switch enables the ECU to select the correct fuel map for idling or normal running. All these sensors feed signals to the ECU. The ECU then controls the injector to give exactly the right amount of fuel to the engine. The injector directs a spray of fuel onto the back of the throttle disc. The amount of fuel delivered depends on how long the injector is held open for, and this period is determined by the ECU. Ignition timing is controlled by the ECU. The high tension is distributed through the rotor arm in the distributor on the end of the inlet camshaft. The ECU controls the idle and fast idle speed by indexing a stepper motor which activates the throttle disc. The idle control system in the ECU can learn the engine load and characteristics. So if a new ECU is fitted, you must do a full tune with microcheck or cobest to enable the ECU to learn the engine characteristics. There's a new 5-speed, robotically assembled, manual gearbox to accompany the 1.4K series engine. The layout of the R65 gearbox is very simple. The main shaft is driven by the engine through the clutch plate. First, second, third, and fourth gears are integral with the main shaft, whilst fifth gear is splined to the shaft and secured with a circlip. The countershaft contains the synchronizer hubs for all gears. No end float adjustment is required during overhaul, and there is no standard oil change in servicing. The final drive is driven from the countershaft and rotates in tapered roller bearings. The selector forks are nylon-tipped to reduce friction. The main and counter shafts are each supported by 2 ball races. The new 216 model uses the well-proven single overhead cam Honda engine. This is an all-alloy construction with a die-cast alloy cylinder block and pressed-in cast-iron cylinder liners. A 5-main bearing forged crankshaft is used. The main bearing caps are strengthened by a bearing bridge which doubles as the main oil gallery. The pistons are graded for fitting. An eccentric rotor-type oil pump is used to circulate oil round the engine. There's an oil pickup strainer in the sump. 16 valves are operated by adjustable rockers from the belt-driven single overhead camshaft. Valve clearance checks are every 12,000 miles. Belt tension is adjusted semi-automatically by a spring-loaded jockey pulley. Access to the belt adjuster is through a grommet in the lower cover. There's the belt cover, cam cover, the crank pulley, alternator and belt. The exhaust manifold has equal length tracts for efficient exhaust gas scavenging, and a cover protects the manifold. The distributor contains the ignition coil and igniter, as well as 3 sensors used by the engine management system. A dipstick completes the picture. The Rover 216 manual gearbox has the 1st to 2nd synchronizer on the counter shaft, the 3rd to 4th on the main shaft, and a separate synchronizer for 5th gear on the main shaft. The final drive runs in ball races. Around the rest of the engine bay is the long air inlet and filter. An engine bay fuse box, a wiper motor, brake fluid reservoir and fuel filter. On the bulkhead is a manifold absolute pressure sensor for the ECU. The distributor contains the coil, the rotor arm, igniter, crank position sensor, cylinder position sensor, and a TDC sensor, all in the one unit. The alternator is at the back of the engine. And there's a compressor for the air conditioning option, complete with its condenser, next to the radiator. A programmed fuel injection system, PGMFI, controls the fuel delivery and ignition timing on the 1.6 litre engine. The single ECU receives inputs from crank position and cylinder position sensors. These enable the ECU to compute the exact speed and position of the engine. A MAP sensor determines the inlet manifold pressure and is connected by a pipe to the inlet manifold. Together with the inlet air temperature sensor, these signals provide the information for the ECU to make a speed density calculation. The coolant temperature sensor provides information for cold running enrichment. A throttle angle sensor measures the position of the throttle disc and its rate of movement. An atmospheric pressure sensor detects altitude changes that may affect air density and fueling. The idle mixture adjuster sensor is a potentiometer to set the idle mixture. All these sensors send information to the ECU. The ECU then calculates how much fuel to deliver through the fuel injectors and provides the correct ignition timing to suit all prevailing conditions. Now let's take a look at the electrical side, with the 214 fuse box and ECU locations, the engine bay fuse box, the in-car fuse box, the MFU, the ECU for the single-point injection system, and the ECU to control the anti-lock braking circuit, which is integral with the modulator. The locations on the 216 are slightly different. the engine bay fuse box, in-car fuse box, the MFU, a programmed ignition ECU inside the car, and the ALB ECU in the boot. Anti-lock braking is an optional extra on both models. There are two different systems, but both operate in a similar way. The anti-lock brake systems prevent the wheels locking under heavy braking. Wheel speed sensors enable the ECU to compute the speed of each wheel. When the ECU detects a wheel is about to lock up, it controls braking pressure to that wheel, preventing actual wheel lock. The 1.4 16-valve models all have solid front discs and rear drums, except when anti-lock braking is fitted and the drums are replaced by calipers as fitted to 1.6 engine cars. The Rover 216 GSI has ventilated front discs and solid rear discs. 4 turns lock-to-lock and rack and pinion steering gives a beautifully weighted steering system, providing a positive feel at speed and easy low-speed maneuvering. The award-winning positive center field power-assisted steering is available as an option on all models. Front suspension consists of well-proved McPherson struts with a forward-facing tie bar, providing very stable steering and improved driver ride. Independent rear suspension consists of double wishbones for exceptional road holding, located fore and aft by trailing arms to improve cornering, even on rough roads. The 216 GSI also has an anti-roll bar. Joint flagships of the range are the 214 GSI and the 216 GSI. Both are equipped to the standard you expect from Rover, with electric sunroof and windows and luxury height adjustable seats. The driving environment is reinforced by the wraparound cockpit, with clear instrument layout and a well-placed gear lever. There are 2 main dials, a tachometer and a speedometer with a trip meter, plus separate fuel and temperature gauges. A warning buzzer will sound if the driver's door is opened with the lights still on. On the GSI models, the driver can vary the level of instrument illumination, and all door mirrors are adjustable from within the car. Remote releases for the tailgate and fuel filler cap are standard on all models. The heating and ventilation controls are clearly laid out and give a wide range of temperature control. The rear seats provide plenty of legroom, and the recessed seat buckles keep everything neatly in place. A courtesy lamp provides rear passengers with a light. The cut pile carpet and moulded door casings give a real atmosphere of quality. All the 5-door models have a 60-40 split folding rear seat to increase luggage room when not required. The Rover 200 is built for quality and designed for style, performance, and easy servicing. And the servicing of the new 200 series couldn't be simpler. Tuning the 214 models can only be carried out using microcheck or co-best. Both are connected to the serial diagnostic connector. There are only 2 adjustments to carry out. One is the electronic adjustment of idle CO through the microcheck keypad or co-best. The other is adjusting the throttle disc air bypass, but this must only be done when prompted by microcheck or co-best. When the test option is selected, the operator is taken through a diagnostic sequence. If a fault is found, details of how to cure the problem are displayed on the screen, and any intermittent faults registered by the ECU will also be shown on screen and on the printout. Tuning a new Rover 216 also has two main elements: the idle mixture adjustment and the base idle adjustment. When you have run the engine to normal operating temperature and carried out all the checks for air leaks, loose connectors and throttle cable adjustment, first check the idle mixture and adjust if necessary. If CO needs adjusting, uncover the PGM-FI ECU to gain access to the idle mixture adjuster. Turn the adjuster by small increments to get the correct reading. Now, to set base idle, disconnect the EAC-V connector and start the engine. Briefly increase engine speed to 1000 revs. Check the base idle and adjust if necessary by turning the throttle body adjusting screw. When correct, reconnect the EAC-V. Remove the hazard fuse for 10 seconds to erase the EAC-V fault from the memory of the ECU. Then start the engine and check CO content and controlled idle speed are correct. A flashing light on the ECU displays any faults registered. The number of flashes indicates specific faults which can be decoded by using the electrical fault-finding manual. To interrogate the system more fully, use the microcheck with a microlink adapter, which must be connected in place of the ECU. The new Rover 200 series, building on success. A finely engineered thoroughbred from Rover. Two brand new engines, both with 16 valves, fuel injection and breathtaking performance. Quality has been built into the product to reflect the Rover mark. Achieved through investment in people, plant facilities and quality to produce a driver's car, the Rover 200 series.